Selecting the right voltage for your machinery is crucial for preventing damage and ensuring efficient operation. There are several factors to consider: manufacturer specifications, voltage drop, and voltage fluctuations. Firstly, adhere to the voltage tolerances specified by the equipment manufacturers. This is paramount to prevent damage and ensure the longevity of your machinery. Secondly, understand voltage drop. Voltage drop occurs when current flows through the resistance in wires and equipment, reducing the voltage at the load end. This is especially important to consider over long distances or with high current draws. Thirdly, power grids typically experience voltage fluctuations. Make sure that the selected voltage range accommodates these fluctuations to avoid any operational issues. Now let's look at the options using 208 volts. Some of the pros are: it falls within the plus or minus 10% tolerance for 220 volts equipment and potentially costs less than upgrading equipment to 480 volts. Some of the cons are: voltage drop could be a concern, especially in hot summer months when line currents and resistance increase. Now, let's examine using 480 volts. Some of the pros are: lower current draw means less voltage drop and cooler operation of equipment. Motors run more efficiently at higher voltages. A con is that it requires upgrading or purchasing new equipment that is 480 volts capable. Another option is using 220 volt. A pro is that it is an ideal voltage for 220 volts equipment, eliminating voltage drop concerns. A con is that it is not directly available from the panel, requiring a transformer to step down from 480 volts or 208 volts. Based on the information, using 208 volts would be a viable option, provided that firstly the 220/440 volts equipment has sufficient tolerance to operate within the 10% tolerance range. Secondly, the installation is designed to minimize voltage drop, such as using larger wire gauges and reducing circuit lengths. Thirdly, the voltage fluctuations are within acceptable limits in your area. If any of the above conditions are not met, it would be advisable to consider using 480 volts, despite the need for equipment upgrades. The higher voltage will mitigate voltage drop concerns and provide more efficient operation, particularly in hot summer months. Remember to always consult with a qualified electrician to ensure the safety and efficiency of your equipment. An electrician can assess your specific needs, inspect the installation, and provide guidance on the best voltage selection for your shop. The manufacturer's specifications are essential to review. This is to ensure that the equipment will operate safely and efficiently at the chosen voltage. Check the nameplate of each machine, which should list the acceptable voltage range. If the equipment is multi-tap, verify that it is correctly configured for the selected voltage. For voltage drop, calculate the expected voltage drop for each circuit, considering the wire gauge, circuit length, and anticipated current draw. Use appropriate voltage drop calculators or consult electrical tables to determine the correct wire size. Keep in mind that the National Electrical Code, or NEC, recommends limiting voltage drop to no more than 5% for feeders and branch circuits. High temperatures increase wire resistance, leading to greater voltage drop. Plan for this by using larger conductors or shorter circuit lengths. Voltage fluctuation should be monitored. Use a voltage meter to monitor the voltage at different times of the day and under various load conditions. Contact the local utility company to inquire about typical voltage fluctuations in the area. If voltage fluctuations are significant, consider using a voltage regulator to maintain a stable voltage supply. When using 208 volts, the advantage is cost savings. It may be possible to avoid the cost of upgrading equipment to 480 volts if the existing machinery can operate safely within the 208 volts range. The disadvantage is voltage drop risk. There is a higher risk of voltage drop, especially with long circuit runs or heavy loads. This can lead to reduced equipment performance and potential damage. To mitigate voltage drop with 208 volts, use larger wire gauges to reduce resistance. Shorten circuit lengths to minimize the distance current must travel. Balance the load across all three phases to distribute current evenly. When using 480 volts, the advantage is reduced voltage drop. Higher voltage means low current for the same power, which reduces voltage drop and energy loss. The disadvantage is higher initial cost. Upgrading or purchasing new 480 volts equipment can be a significant investment. Also, the existing equipment may not be compatible. Assess the cost of upgrading or replacing equipment versus the long-term benefits of reduced energy costs and improved performance. If you are using 220 volts equipment, a pro is that it matches equipment specifications. The equipment operates at its design voltage, maximizing efficiency and lifespan. A con is a transformer requirement. A transformer is needed to step down the voltage from 480 volts or 208 volts, adding to the initial cost and complexity. Choose a transformer with the appropriate capacity and efficiency rating. Ensure it is properly installed and maintained. To minimize voltage drop, use larger conductors and keep circuit length short. Regularly inspect connections and equipment for signs of overheating or damage. Ensure that all electrical work complies with local codes and regulations. For motor efficiency, motors typically run more efficiently at higher voltages, which can lead to energy savings over time. The NEC provides guidelines for conductor sizing and voltage drop calculations in Articles 210.19, A1 215.2, A1 and Chapter 9, Table 9. Use these references to ensure compliance and optimal performance. Consider the long-term operational costs, including energy consumption, maintenance, and potential equipment downtime. A higher voltage system may have a higher initial cost but can offer long-term savings through improved efficiency and reduced maintenance. If voltage fluctuations are a concern, using a voltage regulator can stabilize the voltage supply and protect sensitive equipment from damage. A voltage regulator maintains a constant output voltage despite variations in the input voltage or load. When evaluating equipment, check the voltage tolerance specified by the manufacturer. The tolerance is the range within which the equipment can operate safely and efficiently. Operating equipment outside of this range can lead to damage, reduced performance, or voided warranties. When considering 208 volts, calculate the voltage drop for each circuit under maximum load conditions. Use a voltage drop calculator or consult electrical tables to determine the appropriate wire size. Ensure that the voltage at the equipment terminals remains within the manufacturer's specified tolerance. Consider using a step-up transformer to increase the voltage from 208 volts to 220 volts for equipment that requires it. This can help to improve performance and extend the lifespan of the equipment. When considering 480 volts, ensure that all equipment is rated for 480 volts operation. Using equipment that is not rated for 480 volts can be dangerous and can lead to equipment damage, electrical shock, or fire. Consult with a qualified electrician to determine the best way to convert existing equipment to 480 volts operation. This may involve replacing components, rewinding motors, or installing step-down transformers. Transformers are an important part of the system. If you use a transformer to step down the voltage from 480 volts to 220 volts, ensure that the transformer is properly sized for the load. Overloading the transformer can cause it to overheat and fail. Install a dedicated transformer for equipment that requires a specific voltage. This can help to isolate the equipment from voltage fluctuations and improve its performance. Proper grounding is essential for electrical safety and equipment protection. Ensure that all equipment and electrical panels are properly grounded according to local codes and regulations. Use a ground fault circuit interrupter, or GFCI, to protect personnel from electrical shock. Proper wiring practices are also essential. Use the correct wire size and type for each circuit. Follow all local codes and regulations for wiring installations. Use conduit to protect wires from physical damage. Regular maintenance is also an important part of keeping things in good shape. Inspect electrical equipment and wiring regularly for signs of damage or wear. Tighten loose connections and replace damaged components as needed. Clean electrical panels and equipment to remove dust and debris. Ensure that ventilation openings are not blocked. Consider the overall cost of each option, including equipment costs, installation costs, and operating costs. A higher voltage system may have a higher initial cost, but it can offer long-term savings through reduced energy consumption and maintenance. If you are unsure about any aspect of electrical installation or maintenance, consult with a qualified electrician. An electrician can provide expert advice and ensure that all work is performed safely and in compliance with local codes and regulations. When evaluating the equipment for your shop, consider the energy efficiency ratings of different models. Energy-efficient equipment can save you money on your electricity bill and reduce your carbon footprint. Look for equipment with the Energy Star label. This label indicates that the equipment meets strict energy efficiency guidelines set by the United States Environmental Protection Agency. When selecting motors for your equipment, choose motors with a high efficiency rating. High-efficiency motors consume less energy than standard motors, which can save you money on your electricity bill. Consider using variable frequency drives, or VFDs, to control the speed of motors. VFD can adjust the motor speed to match the load, which can save energy and reduce wear and tear on the motor. VFD can also provide soft starting, which reduces stress on the motor and electrical system. Lighting is another consideration. Use energy-efficient lighting fixtures, such as LED lights. LED lights consume less energy than traditional incandescent or fluorescent lights and last much longer. Use occupancy sensors to turn off lights when they are not needed. Occupancy sensors can save energy by automatically turning off lights in unoccupied areas. Consider using daylight harvesting to reduce the need for artificial lighting. Daylight harvesting uses sensors to detect the amount of natural light available and adjust the artificial lighting accordingly. Heating and cooling is also important. Use energy-efficient heating and cooling equipment, such as heat pumps and high-efficiency air conditioners. Seal air leaks around windows, doors, and other openings to reduce energy loss. Insulate walls, ceilings, and floors to reduce heat transfer. Use a programmable thermostat to automatically adjust the temperature according to your schedule. Programmable thermostats can save energy by automatically lowering the temperature when you are away from your shop or asleep. Consider using renewable energy sources, such as solar panels, to generate electricity for your shop. Solar panels can reduce your reliance on fossil fuels and lower your electricity bill. Conduct an energy audit to identify areas where you can save energy. An energy audit can help you identify energy waste and recommend solutions to improve energy efficiency. Implement an energy management system to track and manage your energy consumption. An energy management system can help you identify trends in energy consumption and identify opportunities for improvement. Train employees on energy-saving practices. Employees can play a significant role in reducing energy consumption by turning off lights when they are not needed, using equipment efficiently, and reporting energy waste. The 208 volts option requires careful voltage drop calculation. Assess the expected load and distance for each machine to ensure the voltage of the equipment remains within acceptable limits, especially during peak operation. The use of appropriately sized conductors is important. Larger conductors can significantly reduce voltage drop. In some cases, it might be necessary to increase the conductor size beyond what is initially calculated to ensure stable operation. To help with voltage drop, consider shortening circuit lengths where possible. Reducing the distance between the power source and the machinery minimizes resistance and voltage drop. A higher voltage, the 480 volts option, may require a more complex setup and additional safety measures. Ensure all safety protocols are followed when working with higher voltages. The 480 volt system might need specialized training for personnel to handle the electrical equipment safely. Regular inspections are crucial to maintain the electrical system's integrity and safety. Check for loose connections, damaged insulation, and any signs of overheating or wear. Proper grounding and bonding are crucial to minimize the risk of electrical shock and equipment damage. Regularly inspect and test the grounding system to ensure it is functioning correctly. A professional assessment by a qualified electrician can help to identify the more suitable and cost-effective voltage option, considering both current and future power needs. Electrical codes and standards, such as the National Electrical Code, provide comprehensive guidelines for electrical installations, including voltage selection, wiring, and safety measures. Staying compliant with these codes ensures a safe and reliable electrical system. Before making a final decision, it is advisable to consult with multiple electricians and electrical engineers to gather diverse perspectives and recommendations. Having a detailed understanding of your machinery's electrical requirements, operating conditions, and potential future expansion plans is crucial for making an informed voltage selection decision. Using energy-efficient equipment and implementing energy-saving practices can not only reduce operational costs but also contribute to a more sustainable and environmentally friendly business. Proper maintenance is a key factor in maintaining the reliability and longevity of electrical equipment. Regular inspections, cleaning, and timely repairs can prevent costly breakdowns and ensure safe operation. Consider the potential impact of power quality issues such as voltage sags, swells, and harmonics on the operation of sensitive electronic equipment. Installing power conditioning equipment can help to mitigate these issues and protect your equipment from damage. By thoroughly evaluating all relevant factors and seeking expert advice, you can make an informed decision about the voltage that best suits your specific needs and ensures the safe, efficient, and reliable operation of your woodshop.